So right now we are working on number 4, which is saying rewrite the equation f of x equal to 0 as x equal to g of x. So my equation is x minus ln x to the power x equal to 0. I can solve it for x equal to something in 3 different ways. One is I will solve for this x, another one is I will solve for this x, and then third one is I will solve for this x inside. Okay, so first one I'm solving for this one. If I want to solve for the first x, ln x to the power x is equal to 0. So what will I do is I will add this term on both sides. So if I add this term on both sides, that will give me x is equal to ln x to the power x, right? So that will be my x equal to g of x form. This is my g of x. This whole one on the right side is my g of x. Okay, now I want to solve for the second x. This one is my second x. I want to solve for this one. So I will start with x minus ln x to the power x, which is equal to 0. Then I will add the same this term on both sides. So that will give me x is equal to ln x to the power x, right? Okay, so something to the power x is this is right now an exponential function. Something to the power x is an exponential function, so I will take ln on both sides to make it simple. Ln x is equal to ln of ln x to the power x. So this x, this is the formula of ln, that ln of b to the power x, this can be any ways, you can bring the power in front, right? Okay, so ln of b to the power x, I can bring this power x in front, so that will give me ln x is equal to x times ln of ln x, and then if I divide both sides by this term, that will give me x is equal to ln x divided by ln of ln x. Okay, now I want to solve for this third x, this one. Okay, so if I want to solve for this third x, I will start from x equal to ln x to the power x. I want to cancel this power x, so I will take x root. If there is a power 2, you will take square root. If there is a power 3, you will take cubic root. There is a power x, I will take the x root on both sides. So that will give me x root of x is equal to ln x. I want to solve this one for the third x, this one. So what I will do right now, I will take, because I have ln x, I want to cancel the ln, I will take e to the power on both sides, exponential. So e to the power x root of x is equal to, if I take e on both sides again, so this e and ln will cancel, you will have an x here. So these are the 3 solution, x equal to g of x form, and one of them, most of the time only one of them work, not all of them always work. So right now we are saying, using fixed point theorem, find an interval having a root of x is equal to g of x. We already know from the intermediate value theorem that there is a root inside 4 to 5, right? We said, we found that from intermediate value theorem. We worked on this problem, that using intermediate value theorem we found there is a root in 4 to 5. Right now what is happening, we are trying to use fixed point theorem. Okay, so what is fixed point theorem? Fixed point theorem is saying if x belongs to an interval, and for this if g of x, for this if g of x also belongs to in the same interval, then there is a root in the interval a to b. Okay, so let's see what is happening if I take, this is my g of x, ln x to the power x. Okay, suppose I am saying x belongs to 4 to 5, then g of x is equal to ln x to the power x. that also need to be belongs to 4 to 5. We need to check that one. So I'm going to the calculator, Desmos calculator. Okay, this is saying ln x to the power x when x belongs to interval 4 to 5. Okay, let me see, 4 to 5. When x is in 4 to 5, we can see g of x is not in 4 to 5, either less than 4 and greater than 5. Okay, so what will happen? Let me make the interval a little bit smaller. Still it is not working. If I say 4 to 4.5, g of x is still out of the interval, right? So what is fixed point theorem is saying, if x belongs to an interval, then g of x also need to belongs to the same interval, then we can say there is a root inside this interval for this function. So this is saying does not belongs to 4 to 5. That means this function will not work. Now we are going to the second one. If x belongs to 4 to 5, then g of x is equal to ln x divided by ln of ln x. Let us see if this one belongs to 4 to 5 or not. Okay, ln x divided by ln of ln x, right? ln x. Okay, so let me check. When x is 4 to 5, but when x is 5, it is going to be less than. So let me check if that work for 4.5. Okay, so I tried to make it 4 to 4.5, but what is happening? G of x is still out of this interval. 4 to 4.5 is not working. 4 to 5 is also not working. The value of g of x is, for this one it is inside the interval, but for this one 5, it is out of the interval 4 to 5. Okay, so this is also not working. Let's check for the third function, e to the power x root of x. Okay, so what will happen on this one? E to the power x root, which is x to the power 1 over x. Okay, and then I'm going to the table 4 to 5. Okay, 4 to 5, let me check. Okay, so when I'm saying x is 4, it is 4 to 5, it is for 4 it is 4 to 5, but for 5 it is not 4 to 5. Let me make the interval a little bit smaller. Right now it is working. So if I take x from 4 to 4.5, g of x is also in 4 to 4.5, right? Okay, so this one is working between 4 to 4.5. When x is inside this interval, g of x is also in the same interval. So this one is working. When x is in 4 to 5, g of x 4 to 4.5 actually, g of x is also in 4 to 4.5. So there is a root x belongs to 4 to 4.5. G of x also belongs to 4 to 4.5. So there is a root in 4 to 4.5 using fixed point theorem. Now we are going to use this rule to find out the root using the iteration. Okay, so what is my root then? X is equal to e to the power x root of x. So we are going to use this one. I'm starting with n is equal to 1. Your x can be anything inside 4 to 4.5, and your g of x is equal to e to the power x root of x. Okay, so your n is equal to 1. Step 1, you can start from anything between 4 and 4.5. So let's start with 4. So it will give you 4.113250. So you are starting with 4. It is giving you 4.11 4.1132504 32504. So in second step, what you are going to do is replace your x by this one and calculate the new x, g of x. Then you will replace x by this one, calculate the new g of x. Then you will replace this one. So we are going to the table to do that in short. Okay, so I am saying I will replace x by 4.11 32504 4.113250, and that is giving me the new value of x, right? 409 4.09 4.09 4.0972 72799. Okay, so what you have 4.099, this is a new value. Now I am replacing x by this new value 4.099 5385 5385, and you can see after fourth step this is your root 4.0992192, right? The more you work, if you take more steps number, then it will give you better answer. So let us check what is the next step giving us 4.099 4.0992192. So you can see as you are increasing the step number, this is 1 2 3 4 5 step, you have the root is correct up to 1 2 3 4 decimal places. Okay, so the question is asking us what is the root after 4 steps, so that will be 4.0992. So after fourth step, your root will be 4.0992. Okay, so here you go with the fixed point technique. Again, I am reviewing a little bit. First thing you need to do is solve the equation f of x equal to 0 as x equal to g of x. So make sure that you can solve one equation in different way as x equal to g of x form, and all of them will not work. Some of them will work, some of them will not. So this is how you need to figure out which one is working, which one is not. If you take x from an interval, then your g of x need to be in the same interval. Then you can find a root in the interval a to b. Okay, so we worked with the first function, it did not work. We worked with the second function, it did not work. We worked with the third function, it did work. So maybe in your case you will also have different way of solving for x. All of them will not work, but some of them will work. Okay, so which one ever work? Like in this one is working, so we are finding the solution using this one in next step using iteration method. So you are using this function for your iteration. First you started with the value of x, calculated the new value of x. Then in the next step you are replacing x by a new value, calculating another value, and so on. So if you go to the calculator, I used x equal to 4, calculated the new value, then we use this new value to calculate another new value, and so on. Okay, so we have after fourth step our root is 4.0992643. Okay, so I'm stopping this video here, and then we are going to Newton's method in the next one.